Here we're going to begin the 7th section of Unit 1, going over applications and literal equations. So the applications portion is going to be these word problems that we're going to read through and take the information that we're given in the sentences to come up with some inequalities or equations that lets us get to our solution. And in the second portion of this lesson, we'll get into some literal equations, which are going to have multiple variables, and then we'll use our inverse operations to get one of the variables by itself. In the first example, we'll read through it first. Dawn won a mini grant of $4,000 to buy tablet computers for her classroom. The tablets she would like to buy cost $254.12 each, including tax and delivery. What is the maximum number of tablets Dawn can buy? So we want to start out by always analyzing what they're asking of us. So in this last sentence, they ask us what is the maximum number of tablets that Dawn can buy. So here, tablets is going to be our variable. So we're going to represent that by x. So looking back at the second sentence, the tablets she would like to buy cost $254.12 each, including tax and delivery. So in that sentence, we're given the information of how much each of those tablets costs. We're going to take the value of the tablet and multiply it times the variable we have for number of tablets to get $254.12 times our variable x. So the total amount that she can spend there on the tablets has to be equal or less than the value amount that she got for the grant. So going back to the word problem, it tells us that the grant here is going to be $4,000. So here the value of her purchase has to be less than or equal to 4,000. Now that we've set up our inequality, we're just going to go ahead and solve it. So using those inverse operations here, if we're trying to get x by itself, right now x is being multiplied by $254.12. To cancel that out, we would divide both sides by $254.12. So it's going to cancel out on the left side of our inequality. And then on the right side, we left with approximately 15.74. So when we think about that answer, and here I've just rounded to the hundredths place, our solution or our statement says that the number of tablets has to be less than or equal to 15.74. And obviously you're not going to be able to purchase 0.74 of a tablet. So the number of tablets that Dawn can buy is going to end up being 15. Looking here at our second example, the problem states Sergio and Lizeth have a very tight vacation budget. They plan to rent a car from a company that charges $75 a week plus 25 cents a mile. How many miles can they travel during the week and still keep within their $200 budget? So you always want to go back to that last sentence and figure out what they are actually asking for. So the last sentence says how many miles can they travel during this week and still keep it within their $200 budget. So what they're asking for is the amount of miles. So how many miles? So here we're going to use x to represent that variable. So x will represent the number of miles. Also in that last sentence, they tell you that they are looking to keep it within their budget of $200. So we know that the total amount that they're going to spend has to be less than or equal to $200. So we'll go ahead and write that right side of our inequality. So looking at the remainder of the information to come up with the left side of our inequality, we see that the company is going to charge $75 a week plus 25 cents a mile. So here we talked earlier about how we made miles our x variable. So here if I just write a little x over miles, I see that for each mile I'm going to pay 25 cents. So I'm going to start by saying 0.25 times x. So every mile I will be paying 25 cents plus the initial charge of $75 a week. So there's our inequality. 0.25x plus 75 has to be less than or equal to 200. So to start solving this multi-step inequality, we always want to cancel out the addition or subtraction first. So looking to get the 0.25x by itself, we want to cancel out the 75 by subtracting it from both sides. After subtracting the 75 from both sides of our inequality, we are left with 0.25x is less than or equal to 125. Now that we've got that variable term by itself, we're just going to divide by that 0.25 on both sides to get x by itself. After dividing both sides by 0.25, we are left with x is less than or equal to 500. So remembering that x is the number of miles, here we see that they can drive 500 or less miles. So make sure you go ahead and just label your answer. So here, answering the question, how many miles can they travel? They can travel 500 miles. Looking at this third, so here in the third example, Ramin's heating bill is $5.42 per month plus $1.08 per therm. How many therms can Ramin use if he wants his heating bill to be a maximum of $87.50? So looking back to see what they're asking how many therms. So usually after those question words, how many or what amount, right? The following word usually is what's going to represent by your variable. So here we're going to use x to represent the number of therms. And sometimes you can just label those here in your problem. So replacing therm with the variable x. The last sentence tells you that he wants to keep the bill, he wants the bill to be a maximum of $87.50. So going down here, we see that maximum is down there in the less than or equal to symbol vocab category. So the most that he wants to spend is $87.50. So whatever's on the left side of this inequality has to be less than or equal to that. So those vocab reference tables on the bottom you can use to come up with which symbol you're going to be using depending on your word problem. So to come up with the left side of our equation, we're looking at that first sentence. Ramin's heating bill is $5.42 per month plus $1.08 per therm. So therm is a variable, so we're going to take the $1.08 and multiply it times x. Then we're going to add on the monthly fee of $4.42. So here we have our inequality. 1.08x plus 5.42 is less than or equal to 87.50. Now we just solve using our inverse operations. So let you go ahead and do that. So here we see that once we subtract the 542 from both sides and divide by $1.08, we wind up with x is less than or equal to 76. So here Ramin can use 76 therms of heat and still stay within his budget of $87.50. So for number 4, I'm going to read through it, and I'm going to just ask that you pause the video and try to come up with your inequality. So here in number 4, Felicity has a calligraphy business. She charges $2.50 per wedding invitation. Her monthly expenses are $650. How many invitations must she write to earn a profit of at least $2,800 per month? So go ahead and figure out what they're actually asking you for. Make sure you represent that variable with the letter x and then come up with your inequality. So you can pause the video now. So using the information given, we see that she's going to charge $2.50 per wedding invitation. So we're going to take the $2.50 multiply it times our variable x. Her monthly expenses are $650. An expense is an amount that she's actually giving up, so that is taking away from her profit. So the $650 need to be subtracted from the money that she's making off the invitations. So now that we have our inequality set up, we're going to solve using our opposite operation, so we're adding 650 to both sides. And then dividing by $2.50. Here we see after we solve that inequality, we get the number of invitations has to be greater than or equal to 1,380. Number 5, Brenda's best friend is having a destination wedding, and the event will last 3 days. Brenda has $500 in savings and can earn, this should say $15 an hour babysitting. She expects to pay $350 in airfare, $375 for food and entertainment, and $60 a night for her share of the hotel room. So how many hours must she work to have enough money to pay for the trip? Once again, here they're asking for how many hours, right? So they're talking about her babysitting hours. So we're going to represent that value with our variable x. Here we see that she's going to get paid $15 an hour for babysitting. So we're going to take 15, multiply it times our variable x. Since here we're getting paid $15 an hour babysitting, and we also have $500 in the savings account. So both of those values have to be greater than or equal to the expenses of the trip. So here we have several different expenses. She's paying $350 for airfare, $375 for food and entertainment, and $60 a night for a share of the hotel room. So here you want to make sure you figure out how many nights she'll be there. Up here they've told you that she'll be there for 3 days. So we'll assume that she'll also be there for 3 nights, right? So we're going to take the $60 a night, multiply it by 3 nights to get us 180 is what she'll end up paying for the hotel room. So now we're going to add all these like terms on the right side and use our inverse operations to solve. So I'll let you go ahead and do that. Pause the video now and do that on your own. So once we solve that inequality, we see that Brenda just needs to have at least 27 hours of babysitting to pay for the trip. Next, we'll take a look at our literal equations. So here we're just solving a formula for a specific variable. And in the problem, to let you know which variable they want you to solve for or get by itself. So you always want to identify which of the variables you're trying to get by itself. This first one, we're trying to get the h variable by itself. So I'm going to just highlight that h. So that is the variable in this equation that we're looking to isolate or get by itself on one side of the equal sign. So the first step in doing this, just like the first step with an equation that you would solve, is to try to get rid of this fraction here. So really we're going to multiply by the denominator to get rid of that fraction. So taking it, multiplying it times the left side, we would end up with 3v. On the right side of our equation, multiplying 3 times 1/3 ends up giving you 3/3, which cancels out to just 1. So we're left with just 1 being multiplied times pi r squared h. Once again, the h is the variable we're looking to get by itself. So looking here, pi and r squared are being multiplied times h. So in order to cancel the pi and the r squared out, we're going to do the opposite operation for both. And here we're just going to do it at the, divide both of them out of there at the same time. So dividing both sides by pi r squared. When you do this on the right side of your equation, both pi and r squared cancel out, just leaving you with the variable h. On the left-hand side, you're going to be left with this fraction 3v over pi r squared. So here is our solution. we've solved for the variable h and got that variable by itself on one side of the equation. So if you wanted to rewrite it so that your variable is on the left hand side, you can feel free to do that. Right, so you can switch the right and left sides of your equation if you prefer to always have your variable on the left side. But either way, you've gotten the variable h by itself, so you've solved that literal equation. Let's take a look at the next one. We're solving for b, so you want to identify where that variable is located. And here, so on the right side of our equation, so we want to cancel out that fraction first by multiplying by the denominator. So we're multiplying this entire equation by the denominator, multiplying the 2 times a on the left hand side gives us 2a, multiplying 2 times 1/2 bh on the right hand side, the 2 and the 1/2 multiplied to make 1, so here we have 1 times bh, or just bh. Now looking to get the b by itself. It's being multiplied with h, so always just identify what operation is going on between your variables to make sure that you do the opposite operation to cancel out that variable. So here we're canceling out the h by dividing it. So looking to divide h on both sides. Cancels out over here on the right hand side, leaving us with our variable b. On the left hand side, we're left with the fraction 2a over h. Next one, they're asking us to solve for the f variable. So to do that, we notice that's inside that parentheses. So it's part of that expression there inside the parentheses. But outside that parentheses, we see we have the fraction 5 over 8. So the 5 over 8 is being multiplied times that. So once again, we're going to just get rid of our fraction by multiplying the whole thing by the denominator. So multiplying the whole thing by 8. 8 times c ends up being 8c. 8 times 5 over 8. So the 8 times 5 over 8 ends up being 40 over 8. 8 goes into 45 times. So here we have 5 on the outside of our parentheses. On the inside we have f minus 32. So we got rid of the fraction, and now we want to get rid of the 5 that has been multiplied times that expression. So to cancel the 5 out, we would divide it. So always use your opposite operations. So the 5 multiplied by 5 divided by 5 on the right hand side cancel each other out. On the left hand side, we're left with 8c over 5 equals f minus 32. And the final step to get f by itself would be to cancel the 32 by adding it to both sides. So once again, on the right hand side, those 32's are going to cancel each other out, and we're left with 8c over 5 plus 32 is equal to f. So here we've isolated our f variable. Once again, all along the way, we're trying to just cancel things out that are on the same side of that variable we're looking to get by itself by using those opposite operations. Looking to solve this equation for lowercase b. So trying to get this lowercase b by itself that's inside this expression. So first we're going to have to try to get that expression by itself. So we're going to start by getting rid of this fraction. So we're going to multiply both sides by denominator of 2. 2 times a is 2a. 2 times 1/2 ends up being just 1. So we're left with h times lowercase b plus capital B. So now we want to get the b variable by itself. So the b variable is inside this expression. This expression is being multiplied by h. So if I want to get rid of the h, I'm going to have to divide both sides by h. H is canceled out on the right hand side. On the left hand side we have 2a over h. right-hand side, we're left with lowercase b plus capital B. So we're just left with that expression that was inside the parentheses. Next, once again, we're trying to get lowercase b by itself. So right now, capital B is being added to lowercase b. So using our opposite operations, we're going to subtract capital B from both sides of our equation. Cancels out on the right-hand side. So we're left with 2a over h minus capital B. Here in this linear equation, 8x plus 7y equals 15. They're asking you to solve for the y variable or to get the y variable by itself. So we're going to start by trying to get the 7y term by itself. So we're going to get rid of this 8x that is on that same side. So since this is a positive 8x, we would subtract it from both sides of our equation. When you do that, cancels out on the left-hand side, leaving you just with 7y. On the right-hand side, you're going to be left with 15 minus 8x, or negative 8x plus 15. And to get y by itself, then you want to divide both sides by 7. So we wind up with y is equal to 15 minus 8x over 7. Notice how dividing that whole expression by 7. So anytime you have multiple terms there, you're doing the operation multiplication and division to both sides. Make sure you're doing that operation to each of the terms. That concludes our 7th section. This is the last section of the unit. So make sure that you are up to date on all your homework quizzes and any Delta Math assignments that you do not currently have a grade for in Delta Math or in SIS. So be sure you check that, and we'll do a little review on Wednesday and take our first unit test on Friday. As a reminder, all of the Unit 1 assignments are due on test day. So make sure that you complete all those homework assignments, so all the homework quizzes and all the Delta Math assignments by Friday.